So this is a very important paper in my view, and it's once again a paper based on randomized control trials and has a good message. The main message is that there are 5 practices, and if you bundle the practices, then things are getting better in schools. So what should you bundle? You could bundle increased instructional time, more effective teachers and administrators, high dosage tutoring, and data-driven instruction, and a culture of high expectations. So if you take these 5 practices together into a bundle, then you will get an achievement which is nice. And here they find 0.15 till 0.18 of a standard deviation a year with respect to the math achievement of high school students, and however little effect on reading achievements. So this is the main message of these RCTs. So it's hard to imagine that something like that could happen in Germany. So because one of the ingredients was to increase time on task, school day was lengthened by 1 hour, so 1 hour longer, and the school year was lengthened by 10 days. So think about that for Germany. But it's not only about Germany, it's about education systems all over the world. Also hard to imagine for Germany is the improvement of human capital in schools. So 46% of teachers left or were removed before the experiment began to get the better teachers to these schools. That's amazing. So what is inspiring is the tutoring model, which was adapted from another school here in Boston, and allows teachers to use interim data on student performance to guide and to inform instructional practice. And this led to what they call high dosage tutoring. In addition to that, and I think that's at least some food for thought, is a culture of high expectations. So if you expect a lot from students, then they feel challenged and want to get better. And this is something I really like. So I also try to challenge you and get a culture of high expectation here in the course, so that you read current stuff, that you read interesting papers. All these papers are available on LIAS. And then what I do here is just help you to go through these papers, and then of course do some interim summaries and to check whether you got all the main messages. So it turned out that these best practices from charter schools, if you insert them into low-performing traditional public schools, that can significantly increase student achievements, especially in math, not in reading. And that might also at least contribute to the elimination of racial achievement gaps in math that has been observed in the past. So here you get a summary of treatment, an overview, so different sites, and these bundle of 5, right? And where you get which treatment depending on the site. So you see in all of these sites you got, for example, the data-driven instruction. So what about the data the researchers got? So they got administrative data, which is good news, right? It's better than survey data, which was provided by some institutions. And the files contained student-level administrative data. So for data protection issues, well, if it's anonymized, that works fine. But as you know, data protection rules are less severe than they are in Germany. So the number of students that have been observed, talk about more than 200,000 students, so this is quite huge sample. And also the outcome, the math and reading tests are standardized. So this is really good data. To test scores, to make them comparable, they're typically standardized or normalized, right? To have a mean of 0 and a standard deviation of 1. That's the set standardization, right? And this is pretty often done here in studies like that to get test score comparable. So now that's a little bit harder to read, but cannot change the format here. What you do is the t-testing, right? You compare the treatment group with the control group, and the null hypothesis is that both are similar, and the null hypothesis cannot be rejected if the p-value is above 5%, and this is true for all characteristics here. And characteristics were female, the share of females in the treatment group and in the control group, the share of white, black, and so on, right? So you could go through all that typical characteristics. So at the end of the day, the H naught that the treatment group average mean is identical to the control group mean with respect to different characteristics, right? So that H naught here cannot be rejected because the p-values are above the 5% level. Like in the previous Banerjee-Duflo paper, they estimate intent to treat effect on ITT. So it's the assignment, right? You're assigned to a treatment or a program group that counts, not if you really get the treatment, right? So this is the ITT effect that is estimated. And then they control for grade level fixed effects and time fixed effects and match pair fixed effects. So if you are not completely sure if there are some other variables that might influence the causal effect, which is here the tau ITT, that's the causal effect. So that's if you estimate that, that's the estimated causal effect of that bundle of 5 practices. And so if you are not sure that there are other things that might influence the causal effect, then you add here fixed effects. So you control, in other words, you control for other factors, right? So these are all fixed effects. You control for other factors. Typically this is done via dummy variables to get rid of the selection that comes from these different variables. So what about biases and the discussion about biases? So here he argues that there's a potential threat to validity, that's the selection out of sample, and saying that, for example, that the best practices that are implemented of charter schools are more likely to have low-performing students exit the sample, then the estimates would be biased even under random assignment. And so they check that and they find 8% of the treatment students are missing a test score relative to 6.6% of the control students. So this is a difference. However, the difference is pretty small, right? It's pretty small, so they don't see that this will change the overall results. So also a local average treatment effect could be estimated. So we'll come to that when we talk about the instrumental variable approach. There we have the idea that there's an average treatment effect only for those who comply with the treatment, so-called compliers. So be patient, we'll come to that later on. So once again, that's a little bit hard to read, but for technical reasons I cannot change that. So let's focus on math. So looking at the ITT effect for the pooled data, so we have that 0.13 of a standard deviation, which is highly significant according to the 3 stars here. And if you take then into account the instrumental variable approach, we will learn later, so the 2-stage least square, this is even a little bit higher. So one of the striking results is discussed here later on. So why are just the achievements in math improved, but not in reading? So this difference in achievement effects between math and reading is an issue, and they try to explain that via several theories that might explain the disparity. This is something that is typically done if you have surprising results. And here they say that it's not really surprising, that's even in line with other papers. And there are several ideas how to explain that. I don't want to go in details here. Yeah, so overall I think this is really a motivating article because we learned something about how we could do things. Also we see the limits, right? We cannot improve everything with such a bundle, but at least with respect to math, that works. And I think our subject, economics, is at least a little bit closer to math and statistics than other social sciences. So maybe it's also something that might help to improve teaching economics.